Okay, let's unpack this. You know that feeling. I think every EV owner knows it intimately. Where you're driving along, maybe the music is playing, the sun is out, everything is great,
Hmm.
and then your eyes dart down to the dashboard. And suddenly, that percentage meter isn't just a number anymore, it's a countdown clock.
The dreaded range anxiety. It's the ghost in the machine. It's that little voice asking, are you sure you're going to make it?
Exactly. It's a psychological thriller happening in real time. And traditionally, the auto industry's answer to this has been, well, pretty blunt.
Brute force.
Brute force. If you want to go further, you need a bigger tank. Or, in this case, a battery the size of a queen-size mattress bolted to the bottom of the car.
Right. You end up with these massive, heavy land yachts.
Hmm.
Sure, they can go 600 kilometers, but you're piloting a tank. You lose the agility. You lose the fun.
But today, we're looking at something that flips that script. We're doing a deep dive into the updated 2026 MINI Countryman E.
Oh.
This is a compact SUV, a car that's famously nimble, city-friendly, and distinctively not a tank that has somehow cracked the code to hit a massive milestone. We're talking about breaking the 500-kilometer barrier.
And here's where it gets really fascinating for me. They didn't do it by just stuffing a bigger battery inside. They didn't just throw mass at the problem.
No, they didn't. This isn't a story about more, it's a story about better. We've got the official press releases from the BMW Group outlining this March 2026 update. We've got technical breakdown reports from the EV report and some specific data on the battery.
So our mission is to figure out how they did it.
Exactly. Our mission today is to figure out exactly how MIN squeezed that extra range out of thin air.
It's a masterclass in what I call marginal gains. It's about looking at the car not as a collection of parts, but as a holistic system where efficiency can be found in the weirdest, smallest places.
So we are going to get into the wires, the physics, and the obsession with detail. But before we get nerdy, we need to set the scene with the headline stat.
The big number?
Because in the world of EVs, that's usually the first thing people look at.
It is, and the number here is 501. Specifically, 501 kilometers on the WLTP cycle for the Countryman E.
That's the magic number, 501 kilometers. Now, to put that in perspective for you listening, the previous iteration of this car, which was already a great car, was sitting at around 462 kilometers.
Which, to be fair, was a respectable number. It was competitive.
It was fine. 460 gets you to work, it gets you to the grocery store, maybe a day trip if you're careful. But hitting 501,
Right.
that feels different.
It's a psychological tipping point.
Totally.
It absolutely is. There's a distinct mental shift that happens to a driver when you cross that 500 threshold. The source material actually leans into this, framing the update around the concept of even more freedom.
Which is usually just marketing speak.
And I'd normally roll my eyes at that, but in this case, the engineering backs it up. At 400 kilometers, you're thinking about your charger. At 500, you're thinking about the destination.
That's a great way to put it. It transitions the car from a city runabout to a legitimate road trip companion. You can genuinely say, hey, let's go away for the weekend, without immediately pulling up a map of charging stations.
Exactly. And it's worth noting, this bump isn't just for the base model. The all-wheel drive version, the Countryman SE All-4, has also seen a jump up to 467 kilometers.
Still a very healthy number.
Very healthy, especially when you consider you're powering two axles. But the 501 figure on the standard E is the headline because it breaks that mental barrier.
Okay, so we have the result, a roughly 40-kilometer jump in range. But here's the mystery I want to unravel. This update is arriving in March 2026. But this isn't a brand new car model, is it?
No, it's not a new generation. It's a technical update to the existing chassis.
So usually if an automaker tells me, hey, we added 10% more range, I assume they changed the shape of the car, they put in a completely new battery platform. But the car looks the same. The battery is physically the same size. So where did these kilometers come from? Do they just ask the electrons to hustle a bit more?
In a way, yes. They ask the electrons to stop getting lost along the way. This is where we have to look under the hood, metaphorically speaking, at the engineering triad.
A triad.
There are three distinct technical changes here that stack up to give you that range.
Let's break them down. What's the first pillar?
The first one is arguably the most significant from a hardware perspective. It's the inverter.
The inverter. Okay, for anyone who isn't an electrical engineer, which is most of us, what is its actual job?
Think of the inverter as the translator. Your battery stores energy as direct current, or DC, just raw power.
Right.
But the electric motor that actually turns your wheels, that runs on alternating current, or AC, So the inverter sits in the middle and rapidly switches the current back and forth to turn DC into AC.
So it's the interpreter between the fuel tank and the engine, effectively.
Precisely. Now, historically, these inverters have been built using standard silicon transistors. They're reliable, they're cheap, they work, but they're also a bit leaky.
Leaky how?
Leaking energy. Every time that switch flips, and it's flipping thousands of times a second, a tiny amount of energy is lost as heat. It's the inefficiency tax.
It's like pouring water from a bucket into a bottle. You're going to spill a few drops on the floor every time.
Exactly. And over a 500-kilometer drive, those drops add up to a lot of wasted range.
So what did they change?
For the 2026 update, MINI switched to a silicon carbide inverter. You'll see it written as SiC.
Silicon carbide. It sounds like something from a sci-fi movie.
It's rapidly becoming the gold standard for high-performance EVs. Silicon carbide is a semiconductor material that's just, well, much more efficient. It allows the inverter to switch much faster with significantly less heat generation.
So going back to the water analogy, you've stopped shaking the bucket, you're pouring perfectly.
That's it. You aren't creating more energy, you are just wasting significantly less of it before it reaches the wheels. That efficiency gain is the biggest single contributor to this range jump.
It's fascinating because it's a completely invisible upgrade. You can't see it, you can't touch it, but it changes the fundamental math of the car.
And that's the theme here, invisible upgrades.
Yeah.
Which leads us to the second factor. And honestly, this was the aha moment for me when I was reading the technical reports.
Oh, what is it?
It's about the battery itself.
Okay, but we established the battery is the same size. I'm looking at the spec sheet. 66.5 kilowatt hours gross energy. That hasn't changed.
The gross energy hasn't changed. That's the physical capacity of the cells. But look at the line below that. Look at the net capacity.
Yeah, I see it. 65.2 kilowatt hours.
Right. In the previous model, the net capacity, the amount the car actually let you use, was lower. They've effectively increased the usable tank size without physically changing the tank.
Walk me through that. Why wouldn't they just let you use the whole thing from day one?
Safety and longevity. Think of a battery like a sponge. If you wring it out completely dry or soak it till it's dripping wet constantly, the material starts to break down.
It degrades.
Exactly. So manufacturers build in a buffer. They say, okay, this is a 66 kilowatt hour battery, but we're only going to let the driver use 64 of them. The bottom and top are locked off to protect the chemistry.
It's a do not touch zone.
That's it. What MINI has done here is a testament to data maturity. They've looked at the data from the last few years, they've refined their battery management system software, and they said, you know what? We know this battery better now. We can safely shrink that buffer.
So they realized they were being too cautious.
Or rather, they realized they could be more precise. They unlocked a room in the house that was previously boarded up. They are letting the driver access 65.2 kilowatters out of the 66.5 total.
That is incredibly smart. It costs them nothing in raw materials. No extra weight, just better software and better confidence.
It is free range, essentially, just by being smarter.
Okay, so we have the silicon carbide inverter and we have the unlocked battery capacity. What's the third factor in the triad?
This third one is the one that really tickles the engineer in me because it is so incredibly granular. It's about rolling resistance.
Rolling resistance.
Specifically, they've introduced friction-reduced wheel bearings on the front axle.
Wheel bearings. Really? We're getting down to the level of individual ball bearings now.
Oh, absolutely. When you're chasing 500 kilometers, every single joule counts.
I mean, how much drag can a wheel bearing actually create?
It's small. In isolation, it's tiny. But think about it. It supports the entire weight of the vehicle while spinning hundreds of thousands of times on a road trip. If there's even a microscopic amount of imperfect friction, the motor has to push just a little bit harder to overcome it.
And you multiply that little bit harder by the front wheels and 500 kilometers.
It accumulates. By refining the surface of those bearings, by using better lubrication, they reduce that parasitic drag. The car just rolls more freely.
It's amazing to think some engineer probably spent 6 months refining a metal ring just to gain maybe
About what?
a kilometer, too?
Probably. But you stack those 2 kilometers on top of the SiC inverter gains and on top of the battery buffer gains, and suddenly you have bridged the gap from 462 to 501.
It really paints a picture of how this industry is evolving. We aren't seeing those massive leaps where range doubles overnight anymore. We're in the era of refinement.
Maturity. That's the word. The technology is maturing.
But let's step back from the microscope for a second. We've been talking about invisible tech, but we need to address the very visible part of this car because, honestly, we have to talk about the look.
We do.
The sources describe it as having an expressive identity. And I have to agree, I think this might be one of the most beautiful electric cars on the road right now.
It certainly stands out from the crowd. It doesn't look like everything else.
They mention a specific favored trim for this update. We've got this blazing blue paint job and this vibrant silver roof that just pops against it.
It's definitely not shy.
It's a min-ani. It's not supposed to be. But what really caught my eye were the wheels. They call it the windmill spoke design. They're massive 20-inch alloys.
It's a very distinct aesthetic.
Yeah.
And frankly, in a market where so many EVs are starting to look like identical bars of soap for aerodynamics, the MI&I managed to keep its soul. It looks blocky, it looks rugged, it looks like a bulldog.
That's a really good point. We usually associate aerodynamic with teardrop shape, the blob look. But the Countryman is an SUV. How does that square with efficiency? Usually beautiful and blocky means terrible range.
That is the magic trick of the design team. You look at it and see a blocky SUV, but the wind looks at it and sees something very different. They've managed to achieve a drag coefficient to seat value of just 0.26.
0.26. For an SUV, that is incredibly slippery.
It is excellent, and that brings us back to those windmill spoke wheels. They aren't just there to look cool. They're almost certainly designed to smooth out the turbulent airflow that gets trapped in the wheel wells.
So the beauty is functional.
Precisely. The contrasting silver roof, the way the mirrors are shaped, the flush door handles, it's all calculated. If that car wasn't as aerodynamic as it is, all the fancy inverters in the world wouldn't get it to 501 kilometers.
So when you look at this car and think, wow, that's a stylish ride, you should also be thinking, wow, that is a triumph of fluid dynamics.
It is. And it proves you don't have to drive a boring car to be efficient.
I want to move inside the car now, because if I'm going to be driving 500 kilometers, I need to know what that experience is actually like.
It is. The centerpiece is still that famous circular display in the center of the dash.
The pizza dish.
The pizza dish, yes. But a very high-tech one. It's a 24-centimeter OLED display. And it's doing a lot of heavy lifting, all the infotainment navigation, but also the visualization hub for the driver assistance systems.
The sources mentioned level 2 autonomous driving. What does that actually mean for the driver on a long haul?
Level 2 means the car can handle steering, acceleration, and braking, provided you're paying attention. It can keep you centered in the lane on the highway.
So it's not take a nap driving, but it's relax your shoulders driving.
Exactly. And that ties back to the road trip concept. If you're doing 500 kilometers, having the car handle the micro adjustments of lane keeping reduces fatigue massively. It makes the range actually usable.
And speaking of usability, we have to talk about space. This is the Countryman. It's the big boy of the Amani family.
It is the largest model. And for families, this is usually the deal breaker. But the stats here are solid. You've got a variable trunk volume that goes up to 450 liters with the seats down.
That's a lot of IKEA boxes.
It is. It fits the dog crate, the sports gear, the luggage for that weekend getaway. It's a genuinely practical vehicle. It strikes a balance.
Let's talk about the one thing that still stops people from buying EVs, even with 500-kilometer range: the charging.
You do eventually have to plug it in. And the charging curve here is optimized well. It supports DC fast charging that can take the battery from 10% to 80% in under 30 minutes.
Which, let's be honest, is basically a coffee break and a bathroom stop.
Exactly. If you've driven 400 kilometers, you should be stopping for 30 minutes anyway. It fits the human rhythm of a road trip.
Now, I want to circle back to efficiency one last time, because there was a specific number in the report regarding consumption. What does it look like on paper?
The Countryman E runs at about 17.4 kilowatts per 100 kilometers on the WLTP cycle.
Is that good?
Yeah.
I feel like we see numbers all over the place.
For a compact SUV, it's very competitive. You have to remember SUVs are naturally less efficient than sedans. To get 17.4 in this form factor is further proof that all that invisible tech is doing its job.
And the all-wheel drive version?
A bit higher, around 18.5 kilowatts per 100 kilometers. That's expected because you have the weight of the second motor and the drag of the all-wheel drive system.
But you get more punch for that trade-off.
Oh, definitely.
Yeah.
The standard Countryman E gives you 150 kilowatts, which is about 204 horsepower. That's plenty zippy.
Right.
But if you step up to the SE All-4, you get a significant bump to 230 kilowatts. That's over 300 horsepower.
And 494 newton meters of torque. That is significant.
It's a rocket ship.
Yeah.
But even the standard model provides that instant electric torque that makes merging onto highways so easy.
So, bringing this all together, we started this deep dive looking at a number, 501 kilometers. But what we found is really a story about the industry growing up.
I think that's the perfect way to frame it. The EV market is leaving its adolescence. We aren't in the Wild West phase anymore. This MI&A update shows refinement.
It's the combination of style and substance. You get the blazing blue paint and the cool wheels, but underneath you have silicon carbide tech, minimizing power loss.
And that brings me to the bigger picture. I think the use of silicon carbide here is a massive signal for the industry.
How so? Because it's trickling down.
Exactly. A few years ago, silicon carbide was exotic. It was for Formula E race cars or million-dollar hypercars. Now we are seeing it in a MINI Countryman. This tells me that high-end performance tech is democratizing much faster than we thought.
It's becoming the new normal.
It is, and it raises a question for the future. We're reaching the physical limits of how big we can make batteries before they become too heavy.
Right, you can't just keep adding weight.
So the next frontier isn't more energy, it's better use of energy. What other invisible upgrades are we going to see? Superconducting motors, active aerodynamics that change the shape of the car on the fly.
That is a fascinating thought. We might be done with the era of bigger is better and entering the era of smarter is better.
I think we are already there.
No.
And this Countryman E, with its 501 kilometers achieved through finesse rather than force, is the proof.
Well, that gives us plenty to think about. It's exciting to see a car that is arguably one of the most beautiful EVs out there, also packing some of the smartest tech under the hood. I want to take a second to give a huge thank you to you, the listener. We know you have a million things vying for your attention, whether you're commuting, working out, or maybe even driving an EV of your own right now. We really appreciate you spending this time with us to geek out over inverters and wheel bearings. It means a lot to us that you tune in for these deep dives.
Absolutely. It's always a pleasure to explore these topics with an audience that cares about the details as much as we do.
We'll catch you on the next one. Drive safe.
Goodbye.